In this video, I'm going to show you how to make this simple multiplayer game, where you can either host or join a server. You can move your character around, type out and send a message that will appear above your character, or you can click on a character and it will display a message showing the ID of the player who clicked it. I have a starting project here. This and the completed project will be available in the description below. We'll begin by heading into the script attached to the main scene. So I have a few things set up in this script. At the very top, an eNet multiplayer peer is created. This is an object that handles all the networking. Typically, this address will be the IP of another machine, but for development purposes, the client will connect to a server on the same computer, which can be achieved by using a loopback address. The standard loopback address is either localhost or 127.0.0.1. The number we use for the port isn't that important as long as it isn't reserved. Generally, the first 1024 ports are reserved, so anything above that should be safe. Next, there are two event handlers for the press signals of the host and join buttons. The host event handler sets the text of a label at the top of the window to server, and the join event handler sets it to client. Each then makes the menu invisible. Lastly, there is an event handler that runs when text is submitted to a line edit named message input at the bottom of the window. We'll start by creating a server. In the host pressed event handler, we'll tell the multiplayer peer to create a server. The first parameter is the port the server will listen to for incoming messages. Right now, the multiplayer peer is just an object in this script class. To tell the game that this is in charge of networking, we set it to the multiplayer peer property on the multiplayer API. Each multiplayer peer on a network has a unique ID. I'll retrieve it by calling getUniqueID in the multiplayer API and display it using another label near the top of the window. Now let's create a client that can join this server. In the join pressed event handler, the code will be mostly the same, except we'll create a client on the multiplayer peer. It takes the IP address of the host to connect to, as well as the port that host server is listening to. I think it's important to point out here that you won't be able to connect to machines over the internet, only those on your local network. There is a pretty easy way to get around this, but that's a topic for another video. Now let's add some player characters. I have a player character scene set up already. Its script has a little bit of code in the physics process function that checks for WASD key presses that move it in 4 horizontal directions, as well as an event handler that runs when the character is clicked. The scene has two child label 3Ds flagged as billboards. One displays the name of the scene, and the other will display a message sent from the player controlling it. There's also an area 3D that detects mouse clicks. Back in the main script, let's create a function called addPlayerCharacter. Inside it, we'll instantiate a player character and add it to the main scene. Then we'll call this function right after the server is set up. Now the player hosting the server has a player character that it can control, but the client still needs one. There are a few signals on the multiplayer peer to help with this. 2 of them run on the client side and the other 2 run on the server. The one we'll be using is peer connected. When a client connects to a server, the peer connected signal will be emitted with the client's unique peer ID. Let's connect a Lambda function to the signal, and inside it we'll make a remote procedural call, or RPC. An RPC is a call made over the network that causes a function in another player's game to run. The network does this by searching remote peers for a node with the same path as the one that made the RPC and calling a specified function on it. The RPC will take the name of the function it's calling as a string. This RPC will call a function called addNewlyConnectedPlayerCharacter. I'll define it below, and inside it will call the regular addPlayerCharacter function. In order for a function to be called remotely by another peer, it must have the @RPC annotation. I'm also going to make the code wait a second before making this RPC. I'm not sure if this is just a bug in Godot Alpha, but it seems like this signal is emitted before the peer is actually fully connected, and it still needs a second before it can start receiving remote procedural calls. Now when a client connects, the server will make an RPC to all previously connected players and tell them to add another player character, including the one that just connected. However, now each player will only have a character for themselves and clients that connect after them. Also, the server's player character is still totally alone. So first we'll give the server's player character some company by calling addPlayerCharacter in the peer-connected Lambda function. Also, let's create an array called connectedPRIDs, add a parameter to the addPlayerCharacter function for the unique ID of the player this character is being added for, and inside the function append that ID to the array. We'll also have to update all the calls to this addPlayerCharacter function with the appropriate arguments. In the peer-connected Lambda, this argument will be newPeerID. addNewlyConnectedPlayerCharacter will now take a newPeerID parameter, and that will be the argument for addPlayerCharacter. We'll also send the newPeerID with the RPC to addNewlyConnectedPlayerCharacter. And in the call to add the server's player character, we'll put the server ID, or 1. Now after the RPC to add newly connected player character, we'll make another, but this time using RPC ID. RPC ID only calls a function on a single peer with a specified unique ID. This RPC will be made to the newly connected peer, call a function that's named addPreviouslyConnectedPlayerCharacters, and take connected peer IDs as an argument. The add previously connected players function will iterate through all of these IDs and add a player character for each one. It's important that this RPC is made before the server adds a new player character to itself, or else connected peer IDs will contain the ID for the newly connected peer as well, causing the newly connected peer to add another character for itself. Each instance of the game now has the correct amount of characters added, although they are overlapping in some instances and their positions are not synchronized across the network. You probably also notice that they all move in unison on each instance. To fix this, we'll change the input to only run if the player character is a multiplayer authority. Is multiplayer authority will return true if the node's multiplayer authority matches the peer's unique ID. At first, this will cause none of the client players to be able to move any of their characters, and the server player will still be able to move all of them. This is because, by default, the multiplayer authority for all nodes on all peers is 1, or the server. We can change a node's multiplayer authority by calling set multiplayer authority on it. So we'll set it in the add player character function to the peer ID parameter. Now for each player, only the character with a multiplayer authority that matches the unique ID of the game instance it's running in will move. To synchronize these movements, we'll send an RPC from the character that is the multiplayer authority to its remote counterparts. The function being called will be named remote set position and take the authority player character's position as a parameter. This function will then set the position of the node receiving the call to this authority position. Add RPC annotations can also have parameters. A good parameter to have here is unreliable. An unreliable call might not reach its destination, and if it does, it might not be received in the same order that it was sent, but they are a lot faster. Since this call is being made 60 times a second, speed is important and nobody will notice if a few packets are lost or out of order. Before this will work, there's just one last thing we have to change. Like I said before, the network will search for nodes with the same path as the one making the RPC. When player character scenes are instantiated, they're given a weird name with @symbols and a number, and this name will be part of the scene's path. Because of this, an authority player character might have a different name than its remote counterpart, or the same name as one that it shouldn't be setting the position of. An easy way to fix this is by setting each player character's name to its multiplayer authority. And now all this movement's working as expected. To add the ability to display messages above characters across the network, I'll create another function called displayMessage, which takes a parameter that it sets to the character's message label 3D. Then in the main script, I'll take the text submitted by the message input line edit, and from here make an RPC on the locally controlled character that is the multiplayer authority. There's just one problem though. We don't have an easy way of figuring out which one that is from the main script. So let's first create a variable called local player character. Then in the add player character function, we'll check if the peer ID of the character being added matches the unique ID of this peer. If so, we'll set the character to this variable. And I'll make the line edit blank and no longer have focus after the text is submitted. Now when we type something, then press enter, it appears above our character on all game instances, except for the locally controlled player. This is because by default, the RPC annotation has the call remote parameter set. This means that the function will only be called on remote nodes and not the one making the call. Adding call local will cause this function to run on the node making the call as well. Another good parameter to have here is the channel parameter. When reliable calls are made, the network will keep them in order with every other reliable call on the same channel. All calls are made on channel 0 by default, and if a lot of calls are being made on the same channel, it can really start to slow the network down. It might be important that these messages are kept in proper order with other messages, but not with everything else on the network, so we can send them on their own channel. Unlike the others, the position of the channel parameter matters. It must be the fourth, so I'll fill out the first three with the defaults, authority and reliable. Lastly, I'm going to add another function that's called remotely when a player is clicked on. It'll be named clickByPlayer, have the call local parameter, and set its message label text to say that the player clicked it, referring to that player by their unique peer ID. The player doing the clicking will be the one making this call, and to get the ID of a peer that an RPC is sent from, you call getRemoteSenderID on the multiplayer API in the function being called. When we run the game, you can see that this only works when a player clicks their own locally controlled player character. This is because by default, RPCs can only be made on a node by the multiplayer authority for that node. Remotely controlled characters are not multiplayer authorities, but they are what make the RPCs when you click them. To allow a function to be called by a node that isn't an authority, you add the anyPeer parameter. And these calls can also go on the message channel. If there's a topic that you'd like me to cover, let me know with a comment below. I hope this video was helpful and thanks for watching.